Hello and welcome back to E341 Introduction to LabVIEW videos. In this video we are going to talk about charts and graphs and what are them, how can we use them, and what are their differences. Mm, in order to start with them, we should know that charts and graphs are tools that show us the information in a graphical way. So in order to see the results of some program, the results of simulating some device, sometimes we need to see how some parameters are changing when time is changing. So in order to do that, we use charts and graphs. They have a very basic difference and they have different applications. We will go through that in this session. So in order to start, like always, we click on a blank VI and we will see our two famous windows, the front panel and the block diagram. And in order to start working with charts and graphs, let's first see what different types of charts and graphs we have. We right click in front panel, we go to this graph palette. You see we have waveform chart, we have waveform graph. So both of these two show waveforms, but one of them in forms of chart and the other one in forms of graph. We have also XY graph, we have also intensity chart and intensity graphs. So let me tell you the basic difference of charts and graphs. Charts show the values in a real-time manner, but graphs do not work in a real-time manner. We will see this difference through the examples that we work on in this video. So let's start with some examples. First, let's go to waveform chart. We right click on the front panel, we go to this graph palette and we select this waveform chart. We put it here. You see that the chart appears here and also here. So in order to see, as I told you, in order to see the um, change of variables and the results of something in real-time form, we use this waveform chart. So as a very simple example, let's put a key here. Let's put a switch here. So we go to Boolean, like always, we put a horizontal switch, and we see that this has appeared here. So we connect this to the waveform chart. So you see that this is not connected. You know why? Because this is Boolean and this is waveform. And you see this also by the colors. This is green, this is orange. So we cannot connect them together. In order to connect this Boolean to the waveform chart, which is used for showing numerical values, we should convert this Boolean into numbers. So in order to do that, we go to this numeric or this Boolean. Yes, and here we see we have Boolean to 0, 1. So we put it here. So we connect this to this, and then we connect this to this. Now this time there is no error, you see. And now this is changed into some blue color, and it's showing some 0, 1 as logic variables. So we will run this program. You see this is going in real time, and when we click on this, we will see the changes in real time form. So in order to see the changes and the differences on the x-axis and on the x-axis and on the y-axis, you can right click on the waveform chart. We go to x scale and y scale, and we can remove the auto scaling. So you see this auto scale for x is removed. Also for y scale, we can remove this auto scale y. We run it again and we see um, them in the waveform chart. So let me stop the program. As another example, let's go and see how we can show a sine wave um, on the waveform chart. So we delete all of these. Let's put a while loop here in order to run what we want and see it continuously in real. So as an example, let's for example sketch sine of pi multiplied by x over 100. In order to make that sine of pi over pi multiplied by x over 100, let's first go and find sine. So we right click, we go to numeric, sorry, we right click, we go to mathematics, we go to then this elementary palette, and then we go to trigonometric, and from here we choose sine and put it here. You saw finding sine was not very easy. So as I told you in the first video, whenever you don't know where is some tool and you know that that tool exists in LabVIEW, we just click on search and we type what we need. So we type sine and we see that we have different types of sine, and we see that this is what we need. So we drag it easily. So instead of going through those menus, we can just search what we need and just drag it. So we need one sine here, and we need pi number. So let's go to numeric and go to this math constants and bring this pi, and then we need to multiply that pi with the loop count, or as we call it here, the loop iteration, I mean. So right click here, we go to numeric, we choose multiplication, and we drag it here. So we connect this pi to the multiplication, and we connect the other one to this iteration. It will be pi x, here it is I, so it will be pi multiplied by the variable, the changing. You see this loop will be run, and every time this will increase, so we will see some variable which is changing continuously. Let's put a divide here, and let's create a constant here in order to define, for example, 100, as I told you in this example. So it will be pi multiplied by I over 100, and then it will be given to sine. So it will be sine of this, you see, sine of this input. And then we connect this to the waveform chart. So let's put a waveform chart here. We go to graph, we put a waveform chart. So this appears here, and we connect the result of sine of this to this waveform chart. And let's put also a condition for stopping this while. In order to do that, we come here, we go to boolean, we define the stop button. As I told you, we should go to properties, and the best way of using this is switch when pressed. So whenever we press this, this will be stopped. So let's connect it to the condition of the while loop, and you see they are connected easily. So now we can run it and see the results. So you see this sign is changing over time, and because this while will be run uh, until we press this stop button, And now you see this waveform chart is showing, because the time is going, but it's showing nothing because nothing is run inside it. So again, and we see the result of this. So in order, so let me stop this. In order to see two waveforms together on top of each other, in order to see their properties together and see their variations together, let's first, for example, add a cosine here and see what will happen if we put them together. So let's go and find cosine. If you remember, we went to mathematics, we went to this elementary, we went to trigonometric, and we can find cosine here. If we don't remember where was it, we can go simply click on search and we search for cosine and we will see it here. No difference. So we want to see cosine of the same thing. So cosine of pi multiplied by I divided by 100. So we simply connect it to the same, the same output. And in order to see both of them on the same chart, let's first delete this wire because we want to see both of them together. We should bundle them together as a cluster. So we go to this cluster palette, we go to this bundle. So you see, now I connect the output of the sine to the first one, the output of this second one, and then the output of the bundle into this. You see, this is a very thick line because it consists of a cluster. So this is like a cluster. So we can see both of them together. Let's run it. Because this was a stop. So you see, we are seeing both of them at the same time. One of them with different colors, you see. So this is basically how chart works and what it gives to us. So we can now stop it. In order to see the changes better, let's put a weight here. So we can create a constant or a control for it. Let's put a control in order to be able to change how much we are giving to this. And you see it is written milliseconds to wait. So whatever the number we put here, it is in milliseconds. So let's run it again. You see that this is running very fast. So let's slow it a bit. Now if we run the while loop, I forgot to press this stop because it was stopped previously. So if we run the while loop, you see that we have sine and cosine together. So if we stop it again, you see nothing is given. Then again we click on this stop in order to run the while loop in the inside operations, and we see. So let's slow it a bit more. So we are seeing what's happening here. Let's stop the program. We can also see different types of shapes here. So we can see them in this form or in this form or whatever the shape that we want. And also we can clear the chart and start drawing the charts again when it's running. So you can right click and you can click on clear chart. So you see from the beginning it will start drawing it. And also we have some useful tools here. So we selected them to be drawn on top of each other. If we don't want them to be in the same chart, we can come, let me stop it. We can right click and we can choose this stack plots. You see this stack plots gives them one by one. So we run it again and we can see them one by one. Also, we can have them as overlay plots again on top of each other, whatever we need and whatever that assignment is asking us to report. Um, so this was about the waveform chart. Let's go to see how we can use the waveform graphs. So let's go and see an example of waveform graph. As I told you, the difference of waveform graph is that it doesn't show us the real-time results, but it shows us what we already have there. So in order to see an example of it, let's go here and let's this time choose for loop. Why for loop? Because we have something to be done and finished and then give it to the waveform chart. So let's create some control for the loop count and let's have our sign again. So we go to mathematics, we go to elementary, we go to trigonometric, we bring our sign. We also go and bring pi. We put an addition, a multiplication here. So multiply the pi by this I and then divide them by 100. So here with this division we create a constant of 100 and we connect the result to the sign. So this will be sine of this, sine of pi multiplied by I divided by 100. This time we connect it to the loop frame. So let's connect it properly. So this is connected to the loop frame. And then we put the waveform graph outside this for loop because this time we want something to be done and then be shown on the graph, because graph is not real time. Graph shows us what we already have. So let's go to this palette and let's bring waveform graph and let's put it outside. Let's connect this to the graph and you should see that it is connected properly. So let's run it. So that we don't have anything here because this is 0. So this for loop is not done and anything is not generated to be shown by waveform graph. So let's put it, for example, 100. And you see this time is 100 and we see something here. So let's put it, for example, 500. Then it will be done 500 times and then it will be shown up here. Also, we can do the same thing that we did with waveform chart and we can show something on top of each other and so on. This time we will use an XY graph in order to do that. So in order to do that, let's go and let's put a cosine here. So let's stop the program. Go to mathematics, elementary, trigonometric, and cosine. And if we forget, we just search for cosine and we will find it as we need. So connect them and we connect this to the border and this is ready to be shown on XY graph. So let me delete this one. Let me get rid of these extra wires by pressing Ctrl B and let's bring an XY graph. So we go to graph, we bring an XY graph, we put it here, we put it outside So we should bundle these two together in order to be shown on an XY graph. So let me use bundle here. We go to cluster, we use the bundle, we drag it here, connect this one to the first and the second one to the second, and connect the result to this XY graph. You see, so now if we run the program, so let's put some number here, for example, I don't know, 1000. If we run the program, now we'll see this sine and cosine together as x and y um, uh, axis. So let's stop the program. So in order to see the effect of this uh, iteration number, let's put it, for example, on 20. So you see, we will see the changes here. So if we increase it, we'll see the effect. So we increase it one by one in order to have a complete figure in this waveform graph. And as you see, here we don't have real-time results shown in the graph. We have some results which are ready and then they are shown in this graph, and they are, you see, they don't change, they are already there and they are shown on the graph. So when we need to see something in real time, we use the chart, and when we need to see something as it's ready, we use the graph. So let's complete this circle. So maybe 200 is enough, yeah. So somehow we see it as here. So that's it for charts and graphs. You saw their differences through some examples.